Hi everyone, and welcome back to Adrian's Digital Basement. On today's video, another midweek mini mail call. Got some more packages here. Let's open some of those up. Let's get right to it. Alright, our first package is from Matthew in Pittsburgh, Pennsylvania. Hi to all my viewers in Pennsylvania. Alright, no note from Matthew. Something in a DigiKey bag. A couple PCBs, and in this one, we have another one. Oh, I know what this is. Alright. Okay, Matthew sent me three things. I'll just move this black one out of the way for the moment. So these two are the same. There are two PCBs. One's obviously pre-assembled and the other one is not. What he's gone ahead and sent me is another RF modulator delete for the Commodore 64, which he has open sourced. Thank you very much. Stuck that on GitHub. I'll put the link in the description. And he sent me one over to test out. Matthew has also sent along a very cool little PCB here. This allows you to use the 5-volt VIC-2 chips, which are found in the short boards, in a long board. That would be the 8562 and the 8565 VIC chip. An adapter like this would be especially useful if you have a long board that has a dead VIC-2 chip and you're able to get your hands on one of the 8000 series VIC-2 chips. This would allow you to safely use that in that machine. So I immediately have a little bit of feedback on these two PCBs. It's one of my pet peeves that people don't write the value of the components on the silkscreen markings. If you're using KiCad to design a PCB, it by default just puts the part number like R11 on there, but it's trivial to just add the label for what this is. Like say this is a 10K, you can put the letters 10K in there and move R11 off to the side. If you're assembling one of these by hand, or say you have one of these boards lying around and you're trying to figure out what components to put on it, if it's just printed right on here, it makes your life a lot easier than having to go find the project and look at the parts that are used and then correlate that R11 is actually a 10K resistor. Here's a PCB that I recently designed in KiCad, and I spent the extra 5 minutes to just put the type of chip it is. So see, it's a 74 ACT 244, and then, 0.01 microfarad cap there, 2.2 resistor, etc., etc. It was really easy to do in KiCad, and it makes assembly later so much easier. So just spend a few extra minutes to do that if you're designing one of your own PCBs, please. Also about this adapter, I have a similar complaint. Now there are no passives on here, so you don't need to write the value of a resistor, but right off the bat, which is the side of the board that faces up? I mean, I guess I'm going to assume it's this one here, because there's a notch there that looks like it's for the socket, I suppose, but it's not 100% clear. If the PCB silkscreen just said something like chip side and motherboard side, or towards motherboard and towards VIC chip, that would remove any ambiguity immediately. All right, before I test out this C64 modulator replacement, I want to do a baseline test with this other C64 modulator replacement that I have in my ZIF board now. This is still the same board I featured in my first and second improving the video quality on a C64 video series. I'll put a link in the description if you haven't seen those yet. Originally, this board had a lot of trouble with rainbow patterns on this 1x1 checkerboard pattern. I'll put a link in the description to this program if you want to download it yourself, but this is the hardest signal for RF modulators to process because this black and white dot pattern is so similar to the NTSC and PAL chroma signal that any amount of this on the Luma channel bleeding over into chroma creates a horrible rainbow pattern. My RetroTink 2X scan converter here is especially prone to picking up any artifacts of that problem, and it reveals itself in this moving rainbow pattern on NTSC. This particular board was really bad with the rainbow pattern because of the way it was coupling the chroma and the Luma signals together to generate the composite video output. So I removed the capacitor that allows the composite signal to be color, and I added 150 picofarad capacitor here, and that completely eliminated the rainbow color pattern. You can see more about that in part 2 of that video series I mentioned. Now, I was corresponding with Matt on his board design about these problems. He designed this board before my video series came out, so this board may or may not have this rainbow pattern, and I'll be very curious to see once I install it into this 64 if this has that problem. So for simplicity's sake, I'm not going to take this whole RF modulator assembly out of here. All I did is I desoldered all the connections that go from the motherboard onto this little yellow board, which is the actual active component. That way this is taken out of circuit completely. And I think what I'm going to do is I'm just going to bodge this in right on top of the other one, right onto these connections here, and that'll do the trick. And there we go. It's like an RF modulator stack. Should do the trick though. All right, let's turn this on and see if we have a picture. Oh, maybe? Oh, yes, we do. Excellent. All right, at first blush, this is looking really good. I'm not seeing any color smearing around the edges here. The text is very sharp. I am seeing sort of an interference pattern that is sort of lines running like this up and down through the color signal. Now, it's not the first time I've seen that interference pattern. Actually, it's kind of gone, oh no, there it is. I just vaguely see it. It's very faint and you might not notice it unless you're really looking for it. I know it's got a couple adjustments on here, so I'm curious what these do. This one's labeled Y and this one's labeled C. And I assume Y is for Luma and C is for the chroma. Y and C are common names for chroma and Luma. This does go back to what I was saying earlier about the silk screen. It would be nice if this actually said Luma next to it and chroma, or chroma level and Luma level. And indeed, I'm turning the one that's labeled Y and the picture is getting dimmer. Chroma signal is not something that's as important from a level perspective, but some monitors have problems if the chroma signal is too hot. So lowering it down might make it work better with your particular monitor. But turning down the chroma signal right now, it's all the way down and it's still fine on the RetroTink. I'm not seeing any issue. Let me turn it all the way up. See if I notice any difference whatsoever. Turning up the color pot on the RetroTink at least does not increase the color. It's not like a saturation control. If there's not enough chroma information, you really have a bad picture and the color might be screwed up. But pretty much once it's working, any amount of chroma voltage is all going to look the same. And that's because the color is not encoded in a way where the voltage matters. It's not amplitude of the signal. It's a dot pattern that gets converted into the colors you see here. So whether the voltage is high or low, it doesn't really affect it. Now, one thing is for sure, at least with my RetroTink, is when the chroma signal is too low, I get that interference pattern that moves through the picture. So turning up that potentiometer got rid of all the interference pattern that I saw on here. So that might be just an artifact of the way the RetroTink works when you have a weak chroma signal. I'm not too sure about it. So let's do the hardest test of all, and we're going to do that pattern where we'll see if the colored rainbows are visible. Matt, I have to give you props. There are no rainbows whatsoever on my C64. This is a great result. Now, even though there are no rainbows on S-Video, if I switch this to composite output, it will definitely have rainbows. And that is something that's unavoidable when you're using composite video. All right, I've removed my pigtail in the S-Video connection and I plugged the composite directly into this green board. Because these are stacked on top of each other, this green board has no components on it, but it does route the composite signal from the output pins here to this RCA jack. And on the RetroTink, we're hooked up through composite and it looks pretty good. It's softer than S-Video, which is completely expected. But let's go to Adrian's tools under test patterns and we'll try out the really tough checkerboard pattern, which I can see already looks like crap. Yeah, this is a really bad rainbow, but it's unavoidable when you have this white and black checkerboard pattern because this matches exactly what the chroma signal looks like on NTSC and PAL, I might add. Now, you may have noticed these jumpers on Matt's board, and what these do is they change a couple of the values on here to make it more appropriate for short boards or long boards. I think from my understanding, the short board VIC-2 outputs slightly different levels for the signals, so you have to change a couple components to make the RF modulator make the appropriate video signals for the right VIC-2 chip. So it's nice that he offers that choice between the two types of boards, and you just move all of these jumpers from this upper position into the lower position. So a big thank you to Matt for sending me this board. I'm glad he did. I'm really intrigued to see that it works perfectly on my machine with no rainbow patterns, while the yellow board that's underneath here did have that problem until I removed a couple components, rendering the composite monochrome. So I'm actually going to leave his board in here because A, I like the fact that it's adjustable, and B, I love the fact that the composite is color again. That was one of the biggest problems with my Ziff board, is I like this machine to be as flexible as possible, and having the fact that this composite was monochrome was a real bummer to me. Check out the link to his project in the description below, so if you need an RF modulator, here's a really good one you can make. All right, here's the next package. It comes from Kentucky, but there was no name on the package, so I'm not sure where it's from. Hopefully there's a note inside. We got a chip, nothing else inside. This is definitely a MOS chip. Ah, well, you take a look at this. It's a little hard to see, but it's a 6581 R4AR Advanced Resonance. This is a SID chip for the Commodore 64, and it's potentially one of the best SID chips, at least of the 6500 generation. So you know what time it is. I have the ZIF64 out. It's time to put this SID in here. This is one of the reasons why I have the ZIF64, because it's just so easy to pop a chip out, pop a chip in. I just don't have to worry about the pins being totally perfectly straight to get them in this board. These sockets make everything so easy. Got the old Easy Flash 3 in here. Let's turn the baby on. Now, one might think I'll go straight to the SID test. Actually, no. I'm gonna go to Donkey Kong Arcade, which means one thing: 8-bit dance party, if the SID works. Is it? Oh, yes! Sounds good. All right, well, for real testing, we got to go to Adrian's Tools, and then we got to run the old SID tester. SID tester by Andrew Challis, hackjunk.com. Don't forget to check out his website. This is my favorite SID tester. If it sounds right in this program, I'm pretty much sure that the chip is working well. So I'm going to do run all tests. All three of these tests need to sound exactly the same, all three voices. This is awesome. This chip definitely seems to be working flawlessly. I'll let the rest of these tests run through. Well, I've been looking through my channel email and I wasn't able to find the viewer who sent me that SID chip. So thank you very much, whoever you are. It's so wonderful that you sent me a working SID chip and one of the AR versions. I have so many bad SID chips. I now have a stack of 64s that sort of are missing half of their heart. I'd say the real heart of what makes a 64 special is the SID chip, of course, and then the VIC-2 chip. These two components together make this machine so special and different than all the other 6502 based machines out there. So thank you again for sending this. That's just amazing. All right, the next packet is from Matt in Toronto. Hi to all my Canadian viewers. Let's see what this is. I am pretty sure I know what this is. I like the recycled packaging. Out comes a little anti-static bag. And what's in here? Ah, yes. What we have here is the PLAnkton. This is a PLA replacement for the C64 that is known for extreme compatibility. And the one thing you may notice compared to the Platinum, which is a PLA replacement I showed off in the GAL PLA video, this doesn't have a voltage regulator on it. On the bottom, there are just a few passive components. And from my understanding, the reason is because this is a Xilinx CPLD that runs natively at 5 volts. So you do not need a voltage regulator on here. If my recollection is right, the Platinum that I showed off in that other video was a 3.3 volt part. And that meant that the Platinum chip was outputting 3.3 volt signals to the rest of the chips on the C64. And while normally a TTL can accept 3.3 volts and see it as a high signal, it's not ideal because some things that rely on that in-between state, like for instance the fast load Epix cartridge, may not work properly. So the ZIF64 is still sitting on the bench, and as usual this machine is sporting the GAL PLA here, which I have shown to be extremely compatible with pretty much everything you throw at it, and also easy and very cheap to manufacture yourself at home. This is one I built myself. But it's my understanding that if you don't feel like building one yourself, the PLAnkton is an extremely good quality alternative PLA. Unsurprisingly, Easy Flash 3 seems to work fine. Let's try loading a replacement kernel. No problems at all. Let's run the Action Replay 5 cartridge. That seems good, working well. And we'll try the final cartridge. That's working as well. Seemingly working without issue. Let's try Super Zaxxon on the multi-easy menu. Now this is not the same as using the actual cartridge, which I don't have a copy of. So I can't actually test that right now with the PLAnkton. No graphical corruption whatsoever. But everything I've read shows that that game works totally perfectly with the PLAnkton. What I can test is something another viewer sent in. It's the Epic's Fast Load cartridge. This cartridge is notorious for crazy things it does on the bus that makes it hard to work with some PLAs. All right, let's give it a try. Very nice. It's totally working without issue. So thank you very much, Matt from Toronto, for sending me the PLAnkton. If it wasn't for Daniel's GAL PLA project, I'd say that the PLAnkton PLA replacement is the chip to buy. And it's still a great choice if you don't feel like building one of these GAL PLAs yourself, because this has such extreme compatibility as well for CPLD-based replacement projects. Well, that's going to be it for this midweek mini mail call. I still have 2 more packages to open, so we'll get to that hopefully next week. I hope you enjoyed this video. If you found it interesting at all, I'd love a thumbs up. If you didn't, you can hit that thumbs down button. Of course, subscribe for more videos. There'll be lots more in the future. And put your comments and your suggestions in the comment section below. Stay safe, stay healthy, and we'll see you next time. Goodbye.